We'll go over study problem 6-11 from our textbook. We are given holding period returns for a company, Zemin Corporation, and for the market index. So luckily those holding period returns are very handy, because otherwise we would have been given the prices. We would have to first come up with the holding period returns, and from there we could have computed the average return and the standard deviation. But as I said, we are lucky, holding period returns are provided, so we'll just go straight forward into our solution. So to begin with, we need the expected return for both companies. We did this previously, so expected return would be simply the average of these numbers. So I assume the problem, I will make a strict assumption that the problem is particularly asking for annualized returns. Okay, so everything here we will annualize it. Previously we solved a problem where we looked at monthly returns, so that's therefore to add a new twist into the problem, we will annualize the result. So let's first figure out by adding a new row here the sum of these numbers. So 6 plus 3, 9, minus 1 is 8, minus 3 is 5, plus 5 is 10. So we have 10% here. And then our monthly return, so we would simply divide by 5. So our average monthly return would be simply 10% divided by 6. So therefore we would get 1.67%. 1.67%. And it's quite simple to annualize this to get average annual return, or we can just say annualized return, annualized expected return, I should say. All we do is we multiply this monthly return by 12, which is just 20%. So this is the expected return for Zemin. In a three-step similar ways, we can find the sum for the market first. 4 plus 2 is 6, plus 1 is 7, minus 2 is 5, plus 2 is 7, plus 2 is 9%. We divide this outcome by 6. We find our average monthly return, which is 1.5%. And to annualize this outcome, we simply multiply it by 12, which gives us an 18% return for the market. So we're pretty much done with the first step. Now in the second step, we need to come up with standard deviations for every single individual investment. Recall that for that purpose, we will look at the squared deviations. So that would be, let me do it the following way. So let me create an additional column here. So this would be the squared deviation here, deviation squared for Zemin, for the company, and this would be the squared deviation for the market. So the squared deviation would be 6% minus, now we should be careful, we should rather use the monthly return here, so 1.67 squared. In a similar way, for the second term, we should have 3 minus 1.67 squared, minus 1 minus 1.67 squared, minus 3 minus 1.67 squared, 5 minus 1.67 squared, and finally 0 minus 1.67 squared. Having done that, we simply add up these numbers. So I will just actually just write down the end result with a different color here. Obviously 6 minus 1.67 would be 4.33. You square it, you get 18.75%. For the second row, you should get 1.77%. Next would be 7.13%. All these figures would be positive. Obviously, you're squaring a number. Ultimately, when you add up all these 6 numbers, you get 63.34. Now make sure you have a good grasp of where did this number come from. It's basically doing the algebra, adding up those 6 rows of numbers. Once we have that, we can find the variance by dividing this number by, instead of 6, by 5 only, because this is a sample. So in the case of a sample, so let me write it here. So for the variance, it would be, for our company, it would be 63.34 divided by 6 minus 1, which is 5. So that number will come out as 12.67%. And further, when we calculate the standard deviation, it would give us a 3.56% standard deviation. All you do is take the square root of that number, which is, as I said, 3.56%. Now we might as well annualize the standard deviation as well. So this standard deviation is monthly. So to annualize it, I simply need to multiply this number by square root of 12. So the standard deviation, annualized standard deviation would be simply, that would be annualized standard deviation. We can apply the same steps to the market. In that case, we would have the following monthly deviations. So it would be 4 minus, recall that the monthly return, average monthly return was 1.5. We square it, then 2 minus 1.5 squared, 1 minus 1.5 squared, minus 2 minus 1.5 squared, 2 minus 1.5 squared, and finally 2 minus 1.5 squared again. So these would be each equal to, so 4 minus 1.5 is 2.5, 2.5 squared is 6.25. I don't worry about the percent sign because ultimately I'll take the square root when I go back to standard deviation, so things will be normal. 2 minus 1.5 is 0.5, 0.5 squared is 0.25, 1 minus 1.5 is again 0.5 squared is 0.25, minus 3.25, 3.25 squared is 12.25, then we have 0.25 here, and then another 0.25 here. When we add up all these numbers, recall we're looking for the sum first, those numbers add up to 19.5% squared, but I don't have to worry about the square. Now when we look at the variance, so all we do is 19.50 divided by 6 minus 1, so basically 5, would give you a variance of 3.90%. Oh, sorry, 3.90 percent square. So, well, yeah, let's just leave it as it is. Let's just say percent for now. And then for the monthly standard deviation, all we do is we divide this number by, sorry, we take the square root, so for that, so the square root of 3.90 would give us 1.97%. And finally, to annualize this outcome, all we do is we multiply this number by the square root of 12. That would be the 6.82% would be an annualized standard deviation, and that would solve the problem, obviously, at least the first part of the problem. So in the next video I will have a look at the second part where we use the capital asset pricing model.